A few more problems in LH rule. I have taken this question, that is limit x tends to 1 minus x square tan pi x by 2. So for our easy way, let us take this as k. Now if you apply limit x tends to 1, this first term will become 0 and this term tan pi by 2, which is infinity. So it's 0 into infinity form. So last video you have seen 0 by 0 form. So 0 into infinity, 0 power infinity, all these things we have to deal only by using LH rule. And now if you see, for LH rule we want one numerator and denominator. So what I'm going to do is, I'll keep this 1 minus x square as it is. Tan theta I'll write it as 1 by cot theta. 1 by cot pi x by 2. Now I have a numerator and I have a denominator. And if we substitute this, numerator will become limit x tends to 1. Let me write this. Numerator will become 0 and denominator also cot pi by 2 is 0 by 0 form. Now I can apply LH rule. What we will do in LH rule, we will differentiate the numerator separately and denominator separately and then we'll apply the rule. 1 if you differentiate 0, minus x square if you differentiate minus 2x, and cot theta if you differentiate it is minus cosecant square theta minus cosecant square pi x by 2 into, and then we have to differentiate this term, that is pi x by 2. Let me write d by dx of pi x by 2. So this is nothing but minus 2x divided by, if I differentiate pi x by 2, pi by 2 is a constant, x if I differentiate 1, so I will get pi by 2, that's it. Cosecant square pi x by 2. And there is a negative sign in the numerator as in denominator, it will get cancelled. And if you try to apply the limit for this term, that is k is equal to, if you apply limit x tends to 1, I have to write here also limit x tends to 1. If I apply x as 1, 2 into 1 by pi by 2 will come to the numerator as 2 by pi, and cosecant square pi by 2, because we have substituted x as 1. Numerator you will get 4. And what is cosecant square pi by 2? That is pi by 2 is 90 degree, right? And cosecant is 1 by sine. What is sine 90 degree? Sine 90 degree is nothing but 1 by 1, which is 1. Denominator we have pi and this one is 1. And hence we got limit x tends to 1, 1 minus x square into tan of pi x by 2. So if we don't have a numerator and denominator, we have to split the problem in such a way that we have one numerator and one denominator, and hence we have to further proceed. Some problems you have to take LCM and simplify. For example, k is equal to limit x tends to pi by 2, 2x tan x minus pi secant x. In this problem, if you substitute pi by 2, again this term will become infinity. And then second term also will become infinity because secant x is 1 by cos. So 1 by cos 90 is 1 by 0, which is infinity. So secant 0 is 1 by cos 0, which is infinity. So this is infinity minus infinity form. We can't proceed further. Hence, let us apply LH rule. But before LH rule, I want one numerator and denominator. How will I proceed further? This tan x I can write it as sin x by cos x. And then secant x I can write it as, just now I told you, 1 by cos x. Now we got the common denominator. Your LCM becomes easy. Hence k is equal to limit x tends to pi by 2. Your numerator is 2x sin x minus pi divided by cos x. Now if you check sin pi by 2, that is this first term, if you substitute sin pi by 2, what we will get? Sine pi by 2 is 1, correct? And hence we will get 2 into pi by 2 also. Let me substitute 2 into pi by 2 into sine pi by 2 minus pi. 2 into pi by 2, this 2 and 2 will get cancelled. Sine pi by 2 is 1. So you will get pi minus pi. So numerator is 0. Cos pi by 2 is again 0, 0 by 0 form. Now we can apply LH rule. So differentiate the numerator separately and denominator separately because this is not a u by v derivative. As per LH rule, we'll differentiate numerator separately. 2x sin x. So now we have this UV rule. Keep x as it is. Numerator, you have both x terms, right? Keep x as it is. Sin x if you differentiate cos x. Plus keep sin x as it is. X if you differentiate 1. And pi if you differentiate will become 0. Divided by cos x if you differentiate, you will get minus sin x. So this is 2x cos x plus sin x by minus sin x. Now if you substitute this as pi by 2, let me write in the next line. That is 2 into pi by 2 into cos pi by 2 plus sin pi by 2 divided by minus sin pi by 2. Now, what is cos pi by 2? Just now, cos 90, 0. So first term will become 0. Sin pi by 2 is 1. Again, denominator 1 more sin pi by 2 minus 1. So the answer is minus 2. So here one more example where this is not in 0 by 0 form, but we are doing the simplification and getting it in 0 by 0 form. Now let us see another type of problems which has the term that is sin x by x or x by sin x. It can be in power also, this power k. This k can be 1 to any number, okay, or x by tan x or tan x by x. When you have such terms, again I'll write power k, and we can use the formulas, that is, let me write. These are the set of formulas when limit x tends to 0, whether it's x by sin x or sin x by x, tan x by x or x by tan x, the answer is 0, 1. Okay, so this limit x tends to 0, any form, the final answer is 1, and this will work only when limit x tends to 0. So we can use this result, and if this comes in any product of the existing problem, we can use this and directly write down the answer. For example, we have k is equal to, let me write down the question as k so that it's easy for me to, limit x tends to 0, tan x minus x by x square tan x. In this problem, if you see, if I substitute x as 0, tan 0, 0, 0 minus 0, numerator is 0. And denominator also will become 0, 0 by 0 form. I can apply LH rule. If I differentiate this numerator, limit x tends to 0. But one thing, if you notice, we have x square tan x here. Whenever this comes in multiplication, I told you that either you have to bring this x by tan x or tan x by x format, because when you see here, the limit is x tends to 0. So what we are going to do is, before applying LH rule, let it be tan x minus x. Numerator x square is there. Here I want tan x by x, means I am multiplying, dividing by x. Now make the problem little simpler, that limit x tends to 0, this fellow is 1. Hence I will write it as limit x tends to 0, tan x minus x by this x square is there, x is there, so I write x cube. Now your problem is easy because this into one more term is coming, right? Limit x tends to 0, x by tan x if this comes to the numerator. I don't have space. Limit x tends to 0, x by tan x. This term will come here. So this value is 1. So I have only this leftover terms, that is tan x minus x. And if I substitute, let me rewrite it, tan x minus x by x cube, limit x tends to 0. Again, this is of the form 0 by 0. Hence, I'll apply LH rule now. So, in this problem, we are eliminating this. If it's in tan x or sin x is in product, and if you have limit x tends to 0, we are simplifying the problem by applying the limit for this particular term. And we can do it only if it is in multiplication. So tan x differentiation is secant square x differentiation is minus 1, x cube differentiation is 3x square. When I substitute limit x tends to 0, now if you see here, the same similar condition is coming. What is secant square theta minus 1? This is nothing but tan square theta. So I'll write tan square x by 3x square. We cannot simplify this problem only by using LH rule, because this, if I differentiate to tan x secant x, again tan x is coming into the scene. Whenever tan x and sin x or something with the combination x is equal to 0, remember that we are going to use the formula. Now I can write this 1 by 3 is a constant. I can throw it outside and I can write this as tan x by x the whole square. So what will happen to the second term? Limit x tends to 0, tan x by x is 1. Hence your answer is 1 by 3. That's it. So if you get any sine or cos terms like this, you can simplify by using the existing formula. See this problem. Limit x tends to 0, 1 by x square minus 1 by sine square x. Obviously, 1 by x is 1 by 0 is infinity, and denominator sine 0, infinity minus infinity form. First, we have to convert it to 0 by 0 form. What we can do? We can take LCM. Multiply sine square x, cross multiply this. So sine square x minus x square divided by x square into sine square x. Now it's a simple LCM. Denominator, if you put x is 0, sine 0 is again 0, denominator is 0, numerator is also 0. Now perfect 0 by 0 form. Now we'll be thinking that we can apply LH rule. Before that, we have to simplify this problem. If you see in denominator, this is in multiplication, which is good for us. So what we can do, the same way in the previous problem, we'll multiply and divide by x square in the denominator. Let the numerator be as it is. So this x square and this x square will become x power 4. And the leftover sine square x by x, I can write it as sine x by x the whole square. Now if I limit apply to the second term in the denominator, what will happen? This sin x by x the whole square, if it comes to the numerator, it is x by sin x. I have written wrong. X by sin x the whole square. Anyhow, this limit is 0. That is why it didn't affect the solution. So the second term will become 1. X by sin x, limit x tends to 0, x by sin x is 1. And hence we are left with only the numerator and denominator x power 4. Numerator is there as it is. We didn't touch the numerator. This denominator x power 4 is there. This term will become completely 1. It is not going to harm us. And if you see this, now it is again in 0 by 0 form. Hence we are applying LH rule. And sine square x differentiation is 2 sin x, and sin x differentiation is cos x. X square differentiation is 2x, and x power 4 differentiation is 4x cube. And 2 sin theta cos theta is sin 2 theta. This is the formula. Minus 2x by 4x cube. And again it is 0 by 0 form. If you see sin 0 is 0, 2 into 0 is 0. And then now we have to apply again LH rule. So sin 2 theta differentiation is, we are here. Sin 2 theta is differentiation is 2 cos 2 theta, because sin differentiation is cos 2x differentiation is this 2. And then second term 2x is there. Obviously 2x differentiation is 2. Denominator we have 4x cube. If I differentiate, 4 3s are 12 x square. It is the d by dx of x power n is n x power n minus 1. Same for. And now we can take 2 common from the numerator as well as the denominator. Numerator 2 is here. Denominator 12 and numerator 2, if it gets cancelled, we'll get 6. Again, this 1 by 6 is a constant. Keep it outside. Now, if you see the numerator, it is cos 2x minus 2. Again, if you differentiate, cos 2x again will become sine 2 sine 2x. And then 12, the 6x square again. You have one more, no, few more steps. Instead, what we can do when it is in multiplication, again, cos 2x minus 1 here, it should supposed to come. Because this 2 I have taken common. So it should be cos 2x minus 1. Okay. So cos 2 theta minus 1 is nothing but minus 2 sine square x. Because we use the formula. Let me write here. Yeah, here is the formula. Cos 2 theta is equal to 1 minus 2 sine square theta. So cos 2 theta plus 1 goes to the other side, minus 1. That is what we have, cos 2x minus 1. I can write it as minus 2 sine square x by x square. Now if you see numerator sine square, denominator x square, it's easy for us. Throw this minus 2 outside, minus 2 by 6 is just a constant. Limit x tends to 0, sin x by x the whole square. Obviously, what is this second term? This is 1. So minus 2 by 6, which is nothing but minus 1 by 3. Hence, in this problem, we have used limit x tends to 0, sin x by x is 1. In the previous problem, limit x tends to 0, x by tan x or tan x by x, anything is 1. Here also, either this or x by sin x. So, how do I know that I have to use this formula? Two things keep in mind. One should be, it should be in product. If you see here, it's in multiplication, minus 2 into sin square x by x square. And second thing is limit x tends to 0. For other limits, it won't work. Limit x tends to 0 is important. And for simplicity, you can multiply and divide by the constant. Here it is default, it has come. But in the beginning, what we did, we multiplied and we have divided. Yes, if you can see here, we have multiplied here and divided by x square because we have sine square. For example, if you have sine cube, we will multiply and divide by x cube. That's it. So you can multiply and divide those constants and hence use this formula and keep this in mind. It should be in product. And the second thing is it should be limit x tends to 0. Thank you.